detail, and then we will teach you how to program your first drone. So let's begin. I'm going to share my screen now, and we will start. Okay, can you see my screen? Yes? Yulia, tell me if you can see.
Yes, we can see this.
Okay, great. So this is our future skills educational part. We will guide you through the basics of programming the drone. Here is the short video where we collected most significant parts of what you can do with our Clover drone platform. This is a fully autonomous drone. It can be used in different applications. For example, here is a competition, RoboFinist, and also RoboFest, another one, where we tested our first steps in swarm robotics. So this is our first attempt, and then you will see how we evolved in just a short period of time. So we always continue to develop this platform, and every new year it can do much more. For example, here you could see autonomous flip in the air, and here a swarm does the same thing. So the swarm of drones that does autonomous flips. Also, our drones are equipped with a camera that can help you to do complicated tasks like following the line. Or you can equip a drone with a 3D sensor camera that helps you to make a 3D model of a person. You can program literally anything with your drone. For example, here you can see how drone grabs some cargo and delivers it to another position. It's also from a competition. So this is a competition for high school, and here we participated in international competitions. And now you can see the swarm of our drones used in theater in a real performance. So this is the first performance with drones in theater in Russia. So this is basically what we can do with Clover platform. Now let's go on to the next slide.
So we use our drone kit in Russian schools, universities, and colleges for mathematics lessons, for lessons of physics and another, and we use it for projects, for different projects. So we have a special portal, a special site with information about this drone, about assembly, about setups, about programming this drone. You can see it if you press link or through the QR code. So there are a lot of information about this drone and how to create new projects with it. The next slide. Any drone consists the same elements. Let's look at the drone. We have VCU. It is a flight controller. It's help drones keep his position in air, and it has some sensors to understand his position in real time. So the next one, it is the power distribution board. It is element this element provides power from battery to each element on drone to electronic speed controller to motors to receiver to flight controller and another. The next one, it is brushless motors. We have 4 motors and we have 2 type motors. It is clockwise and counterclockwise motors. So these motors, I said, brushless. So we need electronic speed controller to control speed on it. Electronic speed controller too. The next one, it is the battery. Battery gets power to drone. It can be 2 cells, 3 cells, 4 cells. We use for our drone actually only 3 cells and 4 cells battery. The next one, it is the remote controller and receiver. You can use it for manual control, but we create autonomous drone in this skills camp. So we will use a remote controller only for control some dangerous situation when you have some mistakes in your code, or drone will, if your drone makes something what you don't wait, unpredictable. So we have it on our drone, but we don't need in it in autonomous drones. The next one, please. Raspberry Pi. Raspberry Pi, it is a microcomputer. It helps to make drone autonomous. For example, if we outside, we can use GPS system to get position our drone. But if we inside, we can't understand where drone, where the floor, where the walls, and Raspberry Pi can calculate position using camera for computer vision and rangefinder, for example. And we will work with it in our lessons today and tomorrow. I know yesterday you has test Raspberry Pi connection with your team coordinators. It wasn't clear for you, I know, but today I think it will be more clear. So we use Raspberry Pi to calculate drone position in different houses inside. So I think Timofey can tell you more about how it works and what we use to calculate drone position.
Yes, thank you, Julia. Here you can see a screen. This is basically what a drone sees when it flies. I will tell you a little bit about how it all connects together, how Raspberry Pi connects to the flight controller, and why it is important. First of all, let's speak about flight controller. We use a Pixhawk type of flight controller. It is based on a PX4 software. It's a firmware for flight controllers. It's an open source firmware, so you can look into the source code and see what's inside. It is a very powerful system because you can extend it with many different sensors, and you can control the drone remotely, autonomously. So what it does, the flight controller maintains stable flight, so it controls the speed of each motor to maintain stable horizontal flight or to tilt the drone to a certain position where it needs to fly. It collects all the data from sensors and also the data of position of the drone and the position is calculated on Raspberry Pi, on the onboard computer. So what is inside the Raspberry Pi? The Raspberry Pi runs Linux operating system. It's a special modified version of Linux that we have assembled it, and we added many necessary packages for working with drones. One of the most important parts of the operating system is ROS. It is a robot operating system. All of the links you can find more information by clicking all of the links. We will give you the presentation afterwards, so you will always have the access to those links. So basically, what ROS does is it connects different sensors, different parts of robots, cameras in one system. And all of the components of ROS can communicate to each other. For example, using ROS, we can take information from camera and put it to the module that recognize markers on the floor. Based on these markers, another module will calculate the drone's position in space. Because all of these markers have unique number to them. Therefore, using the information from camera, you can find where the drone is located indoor, inside of your building, in the place where you fly. After that, using MAVLink protocol, MAVLink is a protocol for communicating with flight controller. So using the MAVLink protocol, Raspberry Pi sends data to the flight controller, and flight controller receives this data and uses it to determine where the drone is located and how does it need to change its position in order to maintain stable flight in the one position if a drone just hovers, or it can take the mission points where to fly. It is also provided by Raspberry Pi. Raspberry Pi sends mission points to the drone, and the drone moves. So basically, Raspberry Pi is used for two main purposes. One of them is determine drone's position in the room, and the second one is run the script that you have written to tell the drone where to fly. We will write script very soon. So once you write a script, you run it on Raspberry Pi, and Raspberry Pi sends information about where the drone should go using MAVLink protocol. And Raspberry Pi is connected to flight controller with a USB cable. So there is a two-way link between flight controller and the Raspberry Pi. I need to emphasize this point that it has computer vision on board. So you can also find more information about computer vision in our knowledge base. There is all of these links lead to our knowledge base. You can click them and see what's there. I will show you very soon how to work with the knowledge base, or maybe you already know how to do that. So this is basically what drone does. But recently we started to develop a simulation platform for our drone, and it is already available for all of you. You can download it for free. Those are the links for the simulator, and we will use it today as well. So let's go to the next step. One of more important concepts of robotics is in which coordinate system you are working. For example, as you can see here, there is a coordinate system relative to the floor, to the specific point at the floor. And here, this is a 0 point, so 0x, 0y, 0z. coordinate, and the drone relatively to this point has coordinates that are non-zero, of course, and you can see here is the same frame but from another angle and from the drone's perspective. So the drone is shifted from this position, and it has specific coordinates. But this is not the only coordinate system that works on the drone. There is also a coordinate system relatively to the drone itself. For example, if you want to write a program that makes a drone fly up from where it is now, just 1 meter higher, you can use the frame, the coordinate system called frame in this case. You can use frame body of the drone to tell the drone, go up 1 meter from your body, from your current position. But this is all relative to the drone. You can put drone anywhere, it will fly 1 meter up from that position. But if you want a precise positioning, you need to use some sort of map for the drone. And Aruco map is a great example of this system. You can see, and you can tell the drone, go to the specific point relative to Aruco map, to the coordinates x2, y1, z1, for example. And every time you run this command, the drone will go to this specific point and will hover around. But the first coordinate system of the drone is called map. And this is basically where the drone, it starts from where the drone was powered on. For example, if you power on your drone on your table, then immediately it will use this point where it was started as a 0 coordinates of the map coordinate system. And when you move the drone from that position, based on the sensors, it will calculate approximately how many meters it was moved and will shift its coordinates in map. But map is not very, it's not precise because it doesn't use any real world objects to calculate its position from. That's why we use Aruco map, which is one of the most convenient ways for navigation. And also, if you work with outdoor drones, the drones that can fly in the streets or in the forest and anywhere else in the open air, you can use GPS position. And GPS gives you latitude, longitude, and altitude. So this is another coordinate system that you can also work with. Later, we will use mostly 2 of this system in our today's lessons, which is body and Aruco map. But you can use many different systems, and I will show you where to find information about them and how you can use them. Now we are coming to this more practical part. How do we control the drone? How do we tell it where to go? This is the example of commands that you can give to the drone, and this is similar to functions. A function that you can either call from a Python script, or maybe you can use another language, or just a console of your drone. And those are some of the most frequently used functions for the drone. They are called actually services, because in ROS, I told you before, robot operating system, there is such thing as services, and services are calling for another program to do certain stuff. If we call the get telemetry service, it will return us, it will give us the information about sensors, about drone's position, its coordinates, its voltage of the battery, its speed, its angles, how it's tilted in the space, and some other information. The next one, I think this is the most used service, is navigate. You can see the parameters that you pass to this service. X, Y, Z, which is coordinates where you go. Then speed, which is the speed at which you will fly. Then frame ID. Frame ID is actually the coordinate system that you want to fly in. For example, you can use body to just go relatively to your own drone, or you can use ArcoMap to be able to go to the certain point on your field. Then the auto arm parameter, which is, it can be either true or false. That tells you if the drone was standing still without flying, without moving propellers, it will power on the propellers and take off. Unless you, I think if you don't set auto arm true, it will not move. The next service is set position. It is similar to navigate, but is more low level because it doesn't have speed, as you can see. So set position, it also does, the drone also moves to a certain point in a certain frame, but at the speed that is most convenient for the drone. For example, if you want to move it to the short distance, it will quickly move to that point. You don't need to set how fast you need to move here. But if you go to much longer distance, it will go very fast. So it is not recommended to use set position for long flights because it will go way too fast and it may hit something. And set position is used when you calculate the desired position frequently, like many times a second, 10 times a second or more. And the distance between each point is low. The next service is land. I think it's, you can really tell what it does. It just lands from the point where it was called. All right. And this is what you need to type in your Python script first before you can write any program. You can find all of this example code in this article. Let me click at this link. All right, so this is the article. This link is always available for everyone on the internet. And there's a Python example where you can just copy this code, paste it into your program, and then continue working on your program. Okay, for writing the program, you just copy that and then call the services. And here you can see get telemetry, I told you about it before, navigate, set position, and land. All of those services I have already discussed with you, but there are other services like set rate, set attitude, set velocity, navigate global. They are all described in this article. They are all described here, but they're not used so often. So if you need more low-level control, or if you want to navigate using GPS, you will use them. But for now, you can just read about them for you to know what Clover platform is capable of. All right. So the next part, I'll pass it to Julia. Julia will tell you how to put your script into the Raspberry Pi and what to do next. Okay, your turn.
Okay. Yes. I would like to tell you about Linux command line. And if you wanted to feel yourself like a real hacker, it's time for it. Because we have not in our image, in Clever image, special graphical user interface. So we will use only Linux command line. And there we will use special commands to make some movements. For example, when you turn on your computer, you can see folders and the files on your screen. In Linux command line, no. You can see only black screen and one line with your computer name, maybe. If you want to see all files and directories in your system, you should use the command ls. It is a list of files and folders. You should just write ls space and enter, and you will see files and directories and folders like at the picture. Can you show, okay, please, all folders and files where ls command.
Can you share your screen and show us live?
No. Just show it with your mouse on the ls command in picture.
Okay. Yes.
Right. Okay. So the next one, if you want open any folder on in Windows or in maybe macOS or in Linux, you just make a double click on this folder and to change directory in command line, you should write command cd, press space, and after it write directory name. It is command number 1, change directory. So you can go to the next directory with the right name. The next one command, it is rm. This command helps us to remove any files or maybe folders, but rm can remove only empty folders. If you want to remove folders with files, you should use special prefix. The next one, it is mkdir command. It allows us to make new directory. You just write mkdir space and directory name, and the new directory will create it. The next one is mv command, move. This command allows us to rename file or directory, for example, or move it from one directory to another directory. The next one, it is nano command. This command, like text editor on in usual operation system, for example, like Microsoft Word or maybe like Sublime Text or like something like any text editor. It allows us to write text in the file. So you just write nana and after it space and after it name of file. So it can create new file if it doesn't exist before, or it can open a file if it exists. The next one, it is Python command. This command allows us to start a Python program. If you write it code in a file, for example, test.py, you just write Python space test.py and your program will run. The next one, it is sudo command. This command allows to run any command or program with super used right. So I think it is not very clear now. So I think we need a little bit practice. Can you open the next slide, please? Where? Yes. Any question? I can hear your question, Ari. Can you write it in the chat, please? Anton, wait, Timofey, can you back to the slide and show the link, please, and QR code? So, and please share this link to chat.
Wait, I need to find the right chat. What is the right chat called?
In chat in Telegram and in chat in Zoom.
Okay, can you wait.
So
Can you copy this link to the chat in Telegram for everyone?
yes, I think I make it. So your task for now, open this link in Zoom chat and make all action what we will show.
Julia, will you show us the demo?
So yes, you can open the terminal screen.
I mean, will you do it yourself with your screen?
No. I think I will tell you, and you will.
Can you see it, fine?
Yes. Okay. One moment, please.
Someone's microphone is not muted.
The first command will ls command. This command show us. Yes, we will mute microphones now. It will be time. Okay. We just input ls and after press enter, and we can see there any files in this directory. If we want to create our directory, new directory, we will use command mkdir. Can you write it, please, Timothy? And we should take some name for this directory. For example, it will be my folder, yes. Okay, and press enter. If we write ls again, we will see this folder in blue color. So if you want, open this folder, we just write program cd change directory, and after it we will write name of this folder. You can use tab to system write any command for you. For example, you just write cd space my, and after it press tab, and system write folder by itself. So the next one, if we want to create a new file, a new program in Python, for example, we will use command nana. For example, nana my program.py. Okay, press enter. Okay, there we can see just a black screen and help menu down. If somebody of you know Python language, it's great. If not, it is okay. Don't worry. Autonomous drone, but there you can see just a simple command. It is a print command, and this command can show some text or maybe some numbers to command line. For example, this program will write text my program to the command line. Okay, for saving it, we will press Ctrl X and after it Y and after it Enter. Okay, if we write ls again, then we can see our program. Who remember what I should write to start this program in Python? Who remember, you can write it to the chat. Okay. Nobody remember? Okay, if nobody remembers, then I tell you. It will Python command. We will write Python space and program name, and just press enter. If we remember, this program just write text to the screen, to the command line. Waiting a little bit time, or we can see our text in the command line. It is easy way to run any program in Python in our system. You will make it with with our programs for autonomous flight too. For example, today you will write your first program for the drone, and you connect to your team coordinator and to workstation with Raspberry, and will try to make the same action. So if I want remove this program, I just write rm and press space and program name, my proc.py, enter. And if I ls and if I input ls again, I will not see this file. Okay, we have a question from the chat. Okay, it's I think it is a question how I close Nano text editor and save it. Timofey, I think we can try to make it again. Can you create file my program again with Nano command? Okay, thank you. And this is our text editor. There we can write any text on any code. And one more thing, I think it is interesting. You shouldn't give to environment type, and you can just write x equals 1 y equals 2 and x plus y give you answer. Can you show it, Timothy, please? Because Python understands it itself. Okay, very good. So now, important moment, how to save file and close this text editor. You should press Ctrl X.
I will tell you here, you can see some tips on what you can do. So this symbol means control and X means just X on your keyboard. So it is basically exit. If I press Control X, it will start exiting. Okay. And this asks me, save modified buffer. I can either press Y or N, or I can press Control C to cancel exit. So I press Y to save it, and then it wants to know at which name to save this file. So file name
You can rename it.
111.py. If I don't want to change anything, I just press enter. Okay, I'm out of the program now, and you can see I have my folder, and I can type ls to find my file 111.py.
So now you can just start it with Python command again.
I press Python, then space, then 1, and I hit tab. It continues to write the name by itself because there is only one file starting with 1. And now I press enter. As you can see, the output of the program is 111 program and 3. 3 is basically x plus y. X was 1, y was 2, and 3 is a sum of these numbers.
Okay, yes. I hope you can make this action on your computer too, and you will try it. So if it is clear, we can go to the next slide. Okay, so I think maybe a little time for relax, maybe 5 or 10 minutes, Timothy. 10. Okay, Timothy, before we start our presentation. Before we can.
Nếu phải
nào có điện cái phao mình là
Okay. Before we continue our lesson, we will have 10 minutes to relax. Meet after 10 minutes in Skype or in Zoom. So let's continue. Timothy, can you open presentation, please?
Yes. Okay. I need to share the screen, but there is already a screen share from Svetlana.
Oh, Svetlana should finish share her screen. Okay, very good.
Wait, I'm about to share it. Okay. Julia, are you here?
I can see presentation.
Yes, and I cannot see you. Can you your camera?
I'm here. So let's continue. Wait, come back. To start work with our platform, with our autonomous drone, you should download special operation system to drone. It is operation system created from our programmers, and they in this operation system has special libraries. It has ROS, it has OpenCV libraries, and it has special interface to program drones easy. So to download this operation system, you should open the link and open our site for Clever. Can you open now, please, Timothy? You just download actual version of image. Press. Oh, okay. Don't download now. It will be long. It will take a long time, but you can download it. And after it, you can write it to the SD card using a special program. For example, we recommended use Etcher, and you can download it from this link too. When you write your image, you just plug in SD card to Raspberry Pi, and your Raspberry Pi create new Wi-Fi, and you can connect to your drone. So let's continue. We already download image and write it to SD card, and we're ready to try create our first program and try start this program on our drone in flight zone. But before, Timothy tell you about program code structure, and he writes this program, and after it I will show you how to upload to the drone and how to start it in a real drone. And Timothy can show you how to test it in a special simulator in Gazebo from his computer. Yes, Timothy?
Yes, I will show you.
Okay.
Okay, so now let's begin writing our code. Everything we need can be found on this website, clover.coex.tech. You already have the link, and the first thing what I do is I go to the article called simple of board, and here I will find the Python example that I need to copy and paste it into my editor. I use Sublime Text Editor. You can use whatever you like. There are many options available, free and easy to use, like Visual Studio Code, Atom, Notepad++, and many others. One of the simplest is Sublime Text. You can easily use it. So first thing you do is paste what you just copied, and don't forget to set the language to Python, because it will highlight the syntax and color our program. Okay, so this is the bone structure of the program. So basically everything you need is already here, and now we can just go and call for the functions for the services that are already available here. What we need to do, let's see here, take off and wait for 3 seconds. Okay, let's write this. For taking off, we'll use navigate service. And let's pass some parameters needed for takeoff. We need to take off to certain height, and let it be 1.5 meters. And this is actually a z coordinate. So we go up to 1.5 meters. And in which coordinate system are we working now? It has to be relative to the drone itself, because depending on where you put the drone on the field, the drone will not see the drone when it's on the ground. It will not see the Aruku markers. It cannot navigate using its computer vision. So you need to provide coordinate system that is already available to the drone, and body is always available for the drone. So we will use frame ID body. But before that, let's choose the speed at which we take off, equals 1 meter per second, which is fine, just a normal speed for the drone. Then now let's use the right frame ID. Frame ID equals quote body. And then the parameter I told you about, called auto arm, equals true. Why do I need to do this? When you are working with a drone on its flight controller, there are different so it can be controlled by your remote controller, or it can be controlled by a program. So you need to put certain mode for the flight controller. And the mode for controlling the drone autonomously is called position control. It is one way for controlling the drone. And another one is off-board. It is fully autonomous. So I need to make sure the drone switches to the off-board mode. For that purpose, we need to provide this argument auto arm true. Otherwise, the drone will not take in the commands. It will just not fly. Okay, auto arm true. We do it once, right when we start. After we land and the motor is turned off, we need also provide auto arm true to take off again. So now the drone will start taking off. But the program will not wait until it takes off. You need to provide some time just for that. And let's see, if we are flying to the height of 1.5 meters at the speed of 1, and we will need some time to gain this speed, we need to give it at least 2 seconds to take off. So let's wait for 2 seconds. So the program doesn't do anything except for waiting it. And you can do it with rosspy.sleep. function. And here we need to tell how many seconds do we need to sleep. Well, 2 will be enough. If you want to give some more time, you can extend it to 5. But let's see what our task is. Take off, wait for 3 seconds. So it needs to wait for 3 seconds after taking off. So we will add 3 to the what we already decided here. So it was 2 seconds for taking off and 3 more seconds to just stay up. And it turns out to be 5 seconds. It's fine time. Okay, the next step is, as we take off, we fly from where the drone was standing up to the point above it. But it is not precise enough. We want to go to certain coordinates. The coordinates are given, and they are 1.0, 1.0, 1.5. And I need to now to navigate using these coordinates and using Aruko map coordinate system. So let's call another navigate and provide x, y, and z. X equals 1, y equals 1, z equals 1.5. Speed equals 1. Frame ID equals Aruko map. Aruko is a type of markers that we use. So these black squares with white squares in it, they're called Aruko markers. They look like QR code, but they're much simpler, and they can only contain a number. But QR code may contain even symbols and so on. So frame ID Aruko map, and I do not need to provide any auto arm true, because by default it is false, and it is okay because we are already in the air, and we need to stay in this position. Okay. As we move to this point, well, the drone starts moving to that point, and we need to provide some time for the drone to go to this point. Let's decide that we put our drone to the 0 position on the map. It means it will take it 1.5, maybe 2 seconds to go to this position, to 1 and 1.5, just to go here. So I need to write rospi sleep again and give it 1.5 seconds just to come to this point. To be precise, it's not exactly 1.5, but I will assume that it will take that much time. But we need to hover for some more time, for 5 seconds. So let's just say it will be 1.5 plus 5 equals 6.5. And then we will land. So this is it. This is our first program, and that we can already launch. How do we launch this program? Well, there are 2 ways that we will show you today. We can run it in the simulator and on the real drone. For running it on a simulator, I will just copy this script and proceed to the virtual machine that is running special Linux operating system. So this is what you can get if you proceed to the link that we have given to you with the simulator. And here, this is just another operating system. I will create a new file. You remember the nano thing? So I can do it right here the same way. So this is my code folder. It is open in terminal and also in this window. If I press nano space, what do we call this program? Take off.py. Py means Python. Take off.py. It creates a new file, and here I can press Ctrl-Shift-V to enter our text. So yes, this is our program that I just written. Control X, Y, and enter. And here you can see a program appeared. Next thing is to run the simulator. It will take some time, and it will also work on a slower speed. It will slow down because of the performance. So this is actually, it requires a quite powerful computer to work on a full speed. But if you do not have a powerful computer, just an average computer will be fine, but you need to know that it will slow down the whole simulation. The simulation will be like maybe half of the speed, or maybe 1/4 of the speed. If you remember the video of the task that we've sent to you, it was recorded right here. This is why a QR code is already here, because I didn't remove it since then. But the drone is running here, and you can see the real-time factor is 0.12, which is a little bit higher than 10% of the speed. So it will take some time for the drone to fly. Next thing what we need to do is call our program. Okay, Python takeoff.py, and let's run. Oh, it says no such file or directory. Why? I think it was here. Oh, I misspelled it. It's a different name. So remember the mv command, mv, which is actually move. For naming the file, you also need to use mv. Mv, I'll write take off. And now I will provide the right name, takeoff.py. Okay, and I have changed the name of the program. By using the up arrow, I can call previously used commands. And now let's run it. It will take more than a few seconds, but it will go just to the position we need it. Here you can see the propellers have started to move, and the drone will take off shortly. Okay, it's now up. It will wait for a few more seconds, then it will go to the position of 1, 1, 1.5, which is right above this marker on the height of 1.5 meters. And here we can see the live video stream from the camera of this drone. Yes, and it is accessible in simulator and in your browser when you run a real drone. So yeah, this is the live stream from the camera. Now the drone will starting to go down. After a few seconds, it will land right above the marker. Okay, so this is how it's easy to write a program. Now I will send this file to Julia just for running it on a real drone. Are you ready, Julia?
Yes, can you send it to general chat in Zoom?
Where?
To chat in Zoom.
I can do this.
I think yes.
Yes, wait.
Oh, and Svetlana helps me now. At first, I would like to show you how drone keeps position with Aruka maps, and after it, we will try to start this program. So, okay, I get in general chat program from Timothy, and now, Timothy, can you finish your screen sharing? Okay. Now I turn on another computer for sharing, where I will start our program this run. So now you can see our flight zone and our terminal. I will show you how to connect with drone a little bit so now I will show you how John keeps his position. Alexei will help me to take off. Hi guys, today I will be your journalist. Now drone holds their position in autonomous mode without remote control. If we change their position, drone return to their initial position again. Они запуски. Yeah. We turn drone to left and drone will come back, and again. Drone remember their position and this polygon. Because drone has known their position using Aruka marker map. Great. Thanks to save our drones. And now we will start an autonomous flight by program. Okay, so now I would like to show you how start this program from computer. At first, you should connect to Wi-Fi. Антон, я могу же отключить сейчас флейвер, отключить снова? Какой это флейвер? Вот этот. Отключается. Я хочу подключиться к нему. Все. So now I connect with Wi-Fi named Clover 5725. Each image has different numbers in name, and it gets this number each in the first start on this image. I think this on this computer we know password from this Wi-Fi, but I think I should to write password from Wi-Fi there. It is password from Wi-Fi network from Clover. The next one, I start PuTTY program. I can start any SSH client, or I can start any terminal if I use, for example, Linux system, or maybe if I use macOS system. But there I should use special program named SSH client, for example, PuTTY. There I write name of IP address of our drone, of our image is 192.168.11.1. And I can save this IP address to connect it to my drone. I just press save. And one more thing to make it more easy, I can write IP there, for example, PI, PI doc, and after it, IP address. So system will not ask us to input username or to input login or username. So now we press save, and I choose it from the table and open terminal. So now you can see it asks me password. Password from Raspberry is Raspberry. So I input it there, but you can't see any symbols because it is special Linux security system. So you can't see any symbols when you input password. But I write Raspberry now and just press enter. Okay, system load, and I can create the new file. For example, first fly. Dot fly. Input the code from Timofey. Okay, how I make? Сейчас хочу открыть. Хочу вот здесь чат открыть. Не могу. Мне нужно код откуда скопировать. So now we open chat. Еще chat. Oh, okay, very good. So now I take code from Timothy from our chat, copy it, and paste it in our program. Okay, so I just press Ctrl C and after it's Ctrl V. So this program saves the save file and close this program with Ctrl X, Y, Enter. I can write command ls and I see my file first flight 0.5. So just so if I want to start this program, I just need to write Python Python space first, and I press step, and program writes the full name of this program. So our team coordinator Alexei will help control drone, because if program will work incorrectly, it can be it can be sometimes but it can be. So already you should look at the picture of polygon or our flight zone, and I press enter now, and drone make take off, fly to the point and land. So we can see how drone take off now. Закажи, что ты не делаешь ничего. So now he just keep his remote control and nothing to do. And drone make his flight. We can make it again. Поставь его в начало. Да, ну куда-нибудь. We put drone to the another point, and it flies again. So now it is on another point. Yes. I can run our program again. Okay, I press enter and drone take off. So it is easy, and I think today your time, and you can try to make the same program by yourself in your team, and our team coordinators will help you in it. So I think I write it there and say, at the first you should take off, and after fly on the by the square. We give you 4 points, 4 coordinates, and you should make program to drone flag to each of these points. Now, our moderator add you to your rooms with your team coordinators, and you start work with them, and you start write your program, and write correct program first, can send it to Timofey or to me, and we start it on real drone and polygon. So I hope our team coordinators ready, and our moderator Anton ready too. 1 minute. And we will send 4 coordinates to your own chat in groups, in your groups, and you can start. I think after 5 minutes. If you're tired, you can relax 5 minutes now. Okay, our moderator asked me, you rename you in Zoom, so we can put group. So you should change your name is in Zoom to name, after its country, and after it your organization. Please make it now. If you have any question, you can ask me now. Still, Anton add you to different rooms. So Да.
Антон, добавьте, пожалуйста, участника из Арабских Эмиратов ко мне в комнату.
Guys, could you turn on your microphone? Mhm. Okay, if you haven't got a microphone, please share your desktop maybe.
Room. I need to be in the UAE team room, United Arab Emirates. Does anybody hear me? Hello? Sure, thank you.
Ребят.
Hello.
Everyone.
Okay, guys, it seems that we're here. Okay, it seems we're all set with Zoom chat. I still don't see Tan in Zoom. Is he still us?
Антон. Антон. Sorry, that would need some time. Идет.
Илья, пожалуйста, скажи всем китайцам, чтобы назвались по Китаю L, Китаю Y и так далее.
Так, Антон, смотри, во-первых, я только что был... Ты всех перекинул в комнату, потому что кого-то, я вот, например, Лиззи, только что видел в другой комнате.
Именно в этой группе те, кто не назвались. Прям в этой группе вообще все участники, которые не названы.
Все участники, которые не названы. Да, сейчас. 大家好，麻烦您改。
是这样吗？
等一下。
делаю。
对，就这样。
OK， 谢谢。
大家呢？
In debugging, we need to connect to Raspberry Pi. Okay, that's I.
We need Okay, now we need connect to HTTP console. So open the PuTTY icon. Good. You hear me? On me very. Which
Singapore, you try reconnect, please.
Okay, right. And please type nano here. N-A-N-O. N-A-N-O. Yes, enter. And you need to copy here your code. Paste here your code. Or code from Clover Gitbook documentation. Use right click for paste. Okay, right. Then you need to write use enter to go to the next string, and then you need to write the code as you hear in lesson. You need to use the navigate command. Please write navigate, yes. Okay. Then bracket, yes. And you need to write X, or you need to write Z coordinate here. For example, Z equals 1.5, 1.5. No. Please delete 1.5. And write Z equals 1.5. This is height this is takeoff height of our drone. Of course, for takeoff, you need to write auto arm parameter column. You need to write column. Or comma, sorry, comma. And my colleague tell you that you need to write auto arm parameter. This parameter is need to switch our copter to off-board mode, because our copter has many flight modes, and
please reconnect to Zoom.
Win sometimes. Can you see demonstration?
Yes.
Now we are starting your code. You can see все хорошо. Now you can see your code in your program. My congratulations, all correct. But we can correct some things with the code to the more interesting result. We can put yav none for more correctly fly.
Sorry, can you say again?
My calculation, your code is full correctly, and but we can correct some things for more interesting result. We go to our code, to your code. I will demonstrate my screen. And now you can see your code. I give you my control to you. And let's try. We can put yav none for to navigate it need to fly without circle,
Okay.
without fly in X, Y in your, for your copter. We need to go in to navigate and put in yeah, none. We can see it in our Gitbook. Let's go to the simple of board from presentation. And this is navigate parameters. And we have one thing, and you have float none. It's flank to point without changing the yaw angle. Let's put this parameter to your code. You can copy and pass to your code to every navigate command.
Brilliant.
One second. Mm-hmm. You can write.
It can't be stick.
Mistake. You can control course with mouth. You need to use keyboard.
Yeah.
And let's try to write your parameter. Yeah. Float down. 1 second. Russian language. Oh, 1 second. And we can pass. Yeah. With we can pass with right click to your mouth.
Okay.
Don't forget about comma.
Okay.
Yeah.
Ready?
Yeah.
Yes.
Yeah.
Ready, steady, and and let's fly. Oh, very quick. Oh no. So I think we make a restart of your system.
Okay. What was the problem actually?
This problem, it can be different. First of all, it can be collect mistakes. So sometimes you need to restart your program, and it's a normal situation for all drones. Don't worry
I thought
about
the
it.
sleep time I put in the program was very less, 2 seconds. Yeah, I should give some more time.
Okay. It can be two. It can be reason if you made very short times for sleep. Your commands can.
Scroll down.
Okay.
I say stop.
Rest sleep and we write lane.
One moment.
Yeah, guys. Yes. Now it will be better, but you forgot one point maybe, and please check your raw sleep time. Please increase it. Yeah,
Okay.
I think it will be helpful.
Okay. Will I edit the program and send another one?
You can send, yes, you can send again,
okay.
checking, but if we have a time before 2 o'clock, we will launch it.
Okay, fine.
And now, guys, I would like to give you inside information. For now, we don't have any query for launching for autonomous flights. And if you send your programming code near time, you will fly again.
Okay.
Женька, ты там как? Рассказывай.
Я нормально вполне. Не знаю, что сказать. Плохо, что я не знаю английский, вот что могу сказать.
Слушай, ну ладно, да и начинай потихоньку пробовать, говорить, это, ну, не страшно. То есть все с этого начинали. Тут главное
Нет,
просто...
всякие такие, я могу составить всякие легкие предложения, а тут ведь нам тематику надо держать.
Ну, да, ну, это технический английский, на самом деле, он не такой сложный.
Вот у меня технический английский начинается в этом семестре. А ты можешь, в принципе, сказать парню, который вот скидывает программу, чтобы он лучше в Телеграме скинул, а не через Google Диск, чтобы я напрямую Лене потом перекинул?
Серьезно. Guys, who is you write the program?
Yeah, I'm
you
Stotam.
can... Yeah?
Yeah.
Okay, Stotam?
Yeah.
Okay. So, Stotam, you can send the program
Yeah, I'm sending on the
to your Telegram group. It will be convenient for us without Google Drive, and we will launch it.
Okay, fine.
У вас там как дела?
Ну, движуха. Всех не хватает. У нас тут прям колл-центр.
А в октябре будет какой-нибудь коптер-хак?
Слушай, у нас Коптерхак сейчас в онлайне, вот,
А.
и это как проект, то есть ты можешь
I have
подготовить...
uploaded in the Google Drive.
Okay. You have uploaded to the Google Drive. Okay.
Yep.
Да, я увидел.
Okay.
Сейчас кину.
Great.
Смотрю.
We will check some methods of transferring your codes, and finally we will choose the best ways to save the time in near days. Okay.
Скажи ему, пожалуйста, что он так, ну вот в загруженном файле у него так и вот пробел, он сейчас лучше экран, да, включу? Нет, не получится у меня, ну ладно. Вот там, где начинается навигейт у него, и ниже у него синтаксис немножко нарушен, потому что пробелы впереди, и не понимает про Python, что от него хотят.
То есть, типа, это проблема Гугла или это проблема того...
Нет, это вроде он так пишет. Вроде бы он так пишет.
Ну, тогда расшарь экран.
Камеру, да, включить? Ой, сейчас демонстрацию.
Ну,
да, сейчас включу.
Экран, да.
Так, вот.
Окей. Что там?
Yep.
During your writing a code, please delete all spaces before stream.
Елена, hello.
Hello? Fragments for launch? Okay. So access. X1 access. X0. 0. Okay. Oh, we can see we're desktop, and we can see test height. Okay.
Hey guys, are you ready?
Yes, we're ready.
Yes. Okay.
Perfect.
Awesome.
Hey guys, are you ready?
Yes, yes, we are.
Okay, good job.
Hey, thank you very much. The first takeoff was a crash. What happened to the first takeoff?
Okay, so you saw your copter flights, and the takeoff was not really smooth because mainly battery was discharged a bit, but at all it performed the square shape, and also recorded the video, so I will send in our Telegram chat in a few seconds. Okay, so you completed successfully the task of the first day.
So are we are we allowed to go home, or is there another task waiting for us?
You're allowed to go home, obviously, but if you want, you can write a function that has not hard-coded sleep time, so that copter checks its current position, and based on its current position, decide whether it should sleep more or it can execute the next line. So as you see now in code, we have something like sleep for 5 seconds, but it can be too much or it can be.
I mean, what is your country?
So now we should run our program. For that, you can write Python in the command line in terminal. And the name of our program, yes.
Actually, both will be better.
Which one?
for simulator than actual drone. Will that be possible?
Yes. Сначала на симуляторе,
Okay.
потом...
Okay, okay.
Okay, thank you.
А мне скинете?
Да, сейчас, подожди. Тебя найду только. Скинул в Телеграме.
Guys, unfortunately, you have only opportunity to test your code on Gazebo simulator with Timofey
Okay.
on real drone because our time is finished, and
Okay.
after it, we will. Okay. See you in briefing. I leave you and stay you with Timofey and Zhenya. Bye bye.
Okay,
Bye.
I can share my screen now. Whose screen is sharing? Is Елена, да?
Да.
А Елена здесь?
Должна быть здесь.
Are you ready?
I think so. You can start.
Okay.
А кто организатор здесь сейчас?
Антон.
Нет, а вот куратор группы.
Я.
Ага, так вы что, Лене дали код тестировать сейчас?
Ну, я так понимаю, ну я и тоже скинул до тебя сначала.
Yes, we are ready to test your code.
Тогда смотрите, меня другая команда еще звала потестировать. Я могу пока отключиться от вас и...
Okay.
А вы только на дроне тестируете. Okay, guys, I will go to check some other code in other team, but right now you're testing it on a real drone, which is just fine.
Okay.
Okay.
А еще высоты.
Ctrl-C. И заведи.
Да. Открой, пожалуйста. Да я бы открываю. Они высоту нигде не установили. Им Z обязательно нужно поставить. Ой, okay. Guys, you forgot about Z position. So now it take off, and after it, he don't understand what the height it has kept. So you should write after y equals 0, for example. You should write z equals and 1.5 meters.
Присоединяйтесь к другим, хорошо?
Да, давай кидай пока.
I hear us.
Я
Guys.
напишу.
Артем, ты здесь?
Чем-то
So I'll connect with my phone and show you what's going on with our
Все
copy.
видео не питает.
Сейчас.
Подожди, сейчас в чат тебе скину.
Okay, now we enter this command to click Control word to right click on mouse. But now we need to add tolerance. Again, it was 5 sleep, and I think again reset.
Hey guys. Hey.
Now press enter and
Егор,
just
тебя еще
right.
нету. Подожди, да, хотя бы
And now we need to only change command to
Я тебя отправил.
this second coordinate of
Ходите все в общий чат. Все, время вышло, лучше приходите.
okay. Sorry. Left and we need join to general chat.
Okay, we take off drone and to general exit general chat. Да.
Press.
I'll show you our drone.
Okay, we take off drone and запускайте.
Okay, now we leave
1 point, 2 point,
room to general chat.
3 point.
and 4 point and length of shutdown. Yeah, nice.
Okay, so we can see our program runs correctly. Поэтому приходит
So guys, very interesting how to how to spend your first classes day. So now I would like to give a couple of minutes to our teachers to finalize your day, and after that I will tell you some words too. So Yulia, let's welcome.
So, hey guys. Okay. So my congratulations for all you, because you make our task and you make it great, really great. Our drone flight autonomous with your code, and it is a very good result for the first day, but it is only start. Tomorrow we'll a little bit more about sensors, about rangefinder, about let's trip and how programming it, and we will study tomorrow all teams what we will use in our final task. So thank you for your attention, and I think maybe Timofey say something.
Yes, sure. I saw the code that you wrote and tested some of them. You did a great job. And tomorrow we'll go more in detail how to build more complicated codes, more advanced codes, and talk about how to get information from sensors, how to write data to files, and it will be much more interesting, I think, and maybe more difficult, but once you learn some basics, it will be just fine for you. So I'm looking forward to seeing you tomorrow and continue our working. Thanks.
Okay, great. Thanks to our great teachers. And thanks for all for you guys for your hard work today. We know about these difficult many difficult subjects, and today you have known many difficult features. And also I would like to offer you to provide and reflection on the day. We will share with you a simple form about how was your day. Please state your opinion. Please leave your opinion, and we have a process. We will process this data and try to improve our skill. Our skill is very best, of course, but we want to make our drone operating skill camp is better. Okay, this is finish for today. Thanks again for your hard work, for our hard work, and see you again tomorrow at 11 o'clock. Bye-bye.
Видосик еще идет.
Что?
Видосик еще идет.
Какой?
Ну, в смысле, это конференция.
Ну все, мы выключаем. Все.
Все, хорошо.
Антон, выключай.